Lesson 7.1, Part 1. Our objective is to use multiplication properties of exponents. Key terms. Base. The number or variable that is multiplied to itself in a repeated multiplication. In the expression a to the third power, 8 is the base. Exponent. The number that represents the number of times the base is to be multiplied. In the expression a to the third power, 3 is the exponent. Power. The expression 8 to the third power is called a product of powers property. Rule number 1. To multiply powers with the same base, you simply add the exponents. Hello and welcome to another edition of the Math Academy. In this lesson, we are going to use multiplication properties of exponents. This lesson actually has 3 rules, but I've broken it down into 3 separate parts to make it extremely simple. The first part, we're going to look at the product of powers property. And there are 8 problems in this first section. We're going to try 4 together, and you'll do 4 on your own. So let's go ahead and get started. This first rule that we're going to look at, rule number 1, it says to multiply powers with the same base, you simply add the exponents, and that's what we're going to do. Now you may be wondering, well, where does that come from? So I have something here to try to show you where that comes from. If I have 3 to the third power, you know that just means to multiply 3 to itself 3 times. So that would be 3 times 3 times 3, okay? And if I have 3 to the second power, you know that simply means to multiply 3 to itself 2 times. So now that becomes 3 times 3. Okay, now let's look at this. How many times have I multiplied 3 to itself? It's going to be 1, 2, 3, 4, 5. So this would become 3 to the fifth power. Once again, the rule says if your bases are the same, and here clearly my bases are the same. My base here is 3. It says to simply add the exponents. So I would add 3 plus 2, and it gives me 5. So that would become 3 to the fifth power. And that's what we just came up with in that example, okay? So that's where it comes from. So let's go ahead and get started doing a couple of examples. Once again, we're going to do 4 together, and then you'll try 2 on your own. Let's look at the first one. I have x to the third power times x to the fifth power. Once again, you look at these bases. My base here is x. So this becomes x. And what did it say to do? You just simply add these exponents. This would become 3 plus 5, giving me x to the 8th power. Okay, that would be my solution. Scroll down a smidge. Let's look at the remaining problems. Let's try this next one together. Now here I have negative 2x to the ninth power times 3x to the third power. Where here I can multiply my numbers together. I have negative 2 times negative 3. And I think I'll go ahead and, let me fix this. I think I'll go ahead and group these together for you. I have negative 2 times 3. And then for my x's, I have x to the ninth times x to the third. Now I have all of my like terms together. So I can multiply negative 2 and 3. That gives me negative 6. Here my bases are the same. So the rule says to simply add your exponents. So I'll add 9 plus 3, which will give me x to the 12th power. So my final answer would be negative 6x to the 12th power. Let's go ahead and take a look at that next one. I'll just go straight down and look at the one right underneath. I have xy to the fifth times 6x to the fourth y to the second power. Okay? So now once again, I think what I'll do, just for the benefit of the people that are learning, or if you're still struggling, I'm going to group like things together. Okay, well, on this side over here on the left, I don't have a number, but on the right, I do have a number 6. So I'll bring that 6 out. It's going to be by itself. Okay, now I'm going to group my x terms together. I have x to the first power times x to the fourth power. Now remember, it is understood when you don't see an exponent there, it's understood that that exponent is a 1. Okay? So grouping everything together, this becomes x to the first power times x to the fourth power. Then I'll group my y terms together. Have y to the fifth times y to the second. So this becomes times y to the fifth times y to the second. Okay? So now I'm ready to simplify this, okay? So I don't have anything to multiply the 6 to, so I'll just bring it down. For my x's, my bases are the same. The base is 8. Remember, it's understood that when you don't see a number there, the exponent is 1. So this is like saying x to the first power times x to the fourth power. The rule says to do what? Add those exponents. We're going to keep that common base. The common base is x. And I'll just add the exponents. 1 plus 4 gives me 5. Once again, same thing for the y terms. The base is the same. I have the y to the fifth, y to the second. The common base is y. I don't need to write it twice. I'll write it one time. That's a common base. And I'll simply add the exponents. That'll be 5 plus 2, and 5 plus 2 is 7. So that'll give me y to the 7th. So that means that my final answer is 6x to the fifth, y to the 7th. It's a fairly simple process. Let's look at this last one together. This one looks a little tricky. This time I have 3 different variables, but I'm going to do the same thing. I'm going to group things together. Now when you're working yours and you get good at it, you won't keep regrouping things. You'll get good at it and you'll just put your numbers together, okay? Your numbers and your variables. So I have an 8 times 4. I'm going to put those two together. Can multiply those two things because they're alike. Then I have p to the first times p to the third power. Those are together because they're like terms. And then I'll have q to the second power and q to the first. So I'll say times q to the second power times q to the first. And lastly, my r variable. I'll have times r to the fifth power times r to the second. Okay, now I'm ready to multiply. 8 times 4 is 32. P to the first power, once again, remember when you don't see an exponent, when you don't see a number there, it's understood that that's a 1. The exponent is 1. So that's P to the first times P to the third. We don't write the variable twice. The bases are the same, so I'll put the common base, which is P, and I'll add the exponents. 1 plus 3, P to the fourth. Same thing for the Q's. Q to the second times Q to the first. My exponent would be 2 plus 1, 3. Okay? And then the last one for the R. I don't need to write the R twice. They have the same base. So I'll simply add the exponents. 5 plus 2 is 7. So my final answer becomes 32 p to the fourth q to the third r to the seventh. This is my final answer. Now, what I want you to do, I want you to pause the video, go back to the first problem. Let me scroll back up for you. I want you to go back to this first problem that we didn't do, and I want you to do the right hand side of the paper by yourself. Then I want you to restart the video and check your answers. Okay, if you've restarted your video, that means you're ready to check your answers. So let's look at the next problem. It's 2y to the fourth times 3y. This time I'm not going to regroup everything for you. I'm just going to go ahead and multiply it out, okay? Because at this point, you should have had enough practice and you're checking your answers. So what are my like terms here? I have 2 and 3. I can multiply 2 times 3, which is 6. And y to the fourth times y. Remember that when you're multiplying exponents, all you're doing is adding the exponents, okay? All you're doing is adding. Also, remember that when you don't see an exponent, it's understood that it's 1. So y to the fourth times y to the first power becomes y to the fifth. That's because 4 plus 1 is 5. So my new answer is 6y to the fifth. My next problem, I have negative m to the fourth n to the fifth times negative m to the second times m to the third. So what are my like variables? I have negative m to the fourth and negative m to the second power. Multiply those two together. I simply add the exponents. So this becomes negative m, and 4 plus 2 is 6. My new exponent is 6. For the n term, I have n to the fifth times n to the third. I want to add those exponents. 5 plus 3 gives me 8. So that means that my final answer is negative m to the sixth power n to the eighth. That's my final answer. The next one, once again, is the exact same thing. I can multiply my numbers together. 3 times 4 is 12. For the n term, for the m term, I have m to the third times m to the second power. What does the rule say to do? You just simply add those two exponents together for your new exponent. 3 plus 2 is 5. So this becomes m to the fifth. Now for my next variable, my n, I don't have another n on this side anywhere. Okay? So I'll just need to bring it down. So that means my final answer is 12 m to the fifth n. And then for the last one, it looks a little messy, but it's okay. It has 3 variables. Once again, you just want to put like things together. Negative 4 times 2 is negative 8. I have x to the fourth times x to the fifth. My base is going to be x. Add those exponents. 4 plus 5, which is 9. So this becomes x to the ninth. So for the y term, I have, let me clean this up a bit. For my y term, I have y to the second power times y to the fifth. Once again, the rule said you simply add those exponents together. You keep that base. So it will become 2 plus 5 is 7. It will become y to the seventh power. And then for that last variable, the z term, I have z to the third times z to the fourth. I know that the base is z, and I'll simply add my exponents. 4 plus 3 is 7. So I'll end up with negative 8 x to the ninth y to the seventh z to the 7th. And that's my final answer. It's a fairly simple process. All it takes is a little bit of practice. Now, please stay tuned for the second part of our video, which will be the second rule, which is a power of a power product. I hope this has been of some use to you, and please view more of our videos. Thank you.